Hi friends, welcome to follow up. In this video, we are going to look at problem 2540, minimum common value. So this problem can be solved by two-pointer trick. So here we are given two arrays, nums1 and nums2, both sorted in non-decreasing order. So we want to return the minimum integer common to both arrays. And if there is no common integer, so we are going to return -1. So here we have two examples. In the first example, so we can see 2 is the one we need to return. And similarly in example 2, so 2 is also the value we need to return. And as for the constraints, so the first item basically says that the length of the two arrays are bounded above by 10 to the power 5. So this basically gives us a problem size upper bound. And the second one basically tells the range of the integers. You can see these integers are positive, and it actually has an upper bound. So this is not that essential for us. So here both nums1 and nums2 are sorted in non-decreasing order. So you can see that in the main statement of the problem and in the constraints, both places emphasize that the two arrays are sorted. Actually, this assumption that the two arrays are sorted greatly simplifies the problem, right? So if you are in a situation that we request a minimum common elements, but the array is not set to be sorted, you can do the sort step first. So here, let me explain quickly what's the two-pointer trick here. So this is a very direct problem. We don't have a lot of logic in between. So we have 1, 2, 3. We have 2, 4, right? So here I have I. Let's see. First pointing to the index 0, and then we have another pointer. Let's say G also to 0. Then we compare the value corresponds to the two pointers. So if the values are the same, for sure we need to return the value. That's the one we are required. Otherwise, so we are going to do comparison. So if this I corresponding to a smaller element, so we are going to move I towards the right in the hope that we can find a larger one which matches the element in G, right? So we move this one further. And in symmetry, so if G corresponds to a smaller value, we are going to move G to the right, right? So in this case, we know now nums1i and nums2g are the same, so we can return these two. So if we change a value, for example, this 3, so these two are still not the same. Then in this case, G is smaller, so we're going to move to the right. And then we compare the two values again. Then 3 is smaller than 4, so we are going to move I to the right again. So now we have 3 and 4. They are still not the same, and I corresponding to a smaller value, so we are going to increment this I. So then this I will be out of bound compared to the length of the first array. So in this case, we should stop. In this case, nothing common in the two arrays. We should return -1. So this is actually a dynamic demonstration of the procedure. So as to writing the code, actually it's rather straightforward. So what you can do is that you have I, so pointing to the beginning of the first element, first array, and J corresponding to the second array. In order to do it more, save some typing, so I'm going to change this one to be A and this one to be B. And then what we are going to do, so well, I is less than the length of A, and J is less than the length of B. So notice that here I'm using the logical relation add, right? So if, in other words, if one of those auto bound, either I or J auto bound, then we should stop. So here we can do comparison first. If AI equals BJ, so we can return AI. Otherwise, if AI is smaller, so than BJ, so we should push I to the right, so I plus equals 1. Otherwise, it means that AI is larger, so we are going to push J to the right. And then afterwards, if nothing has returned among the while loop, so we are going to return -1. which means there are no common elements among the two arrays. So this basically solves this problem using this trick. As we mentioned, that the problem actually emphasizes that the two arrays are in sorted order. If you are request to find the minimum common element, but without telling that the two arrays are in sorted order, you can first do the sort. But here, one thing we need to notice is that, so this algorithm, the term complexity will be O of the n plus m, the length of the two arrays, or the larger ones, so that's more precise. But if you do sort, so sort is nothing but O logarithm n up to a constant, right? So this n is iterable length. Right, you can, so I'd prefer to use this, but you can also use this big O notation, right? So before we close this, let's do a quick test. So we have it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, I guess that's about it for this challenge problem. Thank you.